Welcome to Department of Botany, Kalna College. Myself, Dr. Somnath Mondal. Today's topic is the basic idea of inflorescence. In this video, I have included the different types of Racemose and Cymose inflorescences and their probable line of evolution. And I have excluded the compound, mixed and special type of inflorescences from this video class, and they will be incorporated in the next class. So in this class, the basic idea of inflorescence, racemose, cymose and their evolution. First of all, what is an inflorescence? An inflorescence usually means a branch system where group of flowers are arranged on a branched or unbranched axis. Now the main axis of the inflorescence is called peduncle or rachis, and this is the peduncle. On peduncle, flowers may have stalk or pedicel, and then we will call them as pedicellate flowers, or maybe without stalk, that is flowers may be sessile. Now inflorescence can be classified into two main types, racemose and cymose. In case of racemose, the rachis grows indefinitely. It never ends in a flower, and flowers bloom in acropetal or centripetal succession. We will come to the point of acropetal and centripetal. And what does it mean? Now let's have a look at cymose first. It is almost the opposite. That is, rachis never grows indefinitely. There is a definite length of rachis. It ends in a flower, and flowers bloom in basipetal or centrifugal succession. Now let's see the diagram. So on pedicel, on peduncle and pedicel, flowers are there, and the lowermost flower blooms first, and thereafter the apical buds are there. So therefore the lowermost bud has been matured first, and then thereafter towards the apex. That is why this is called acropetal. So flowers are blooming in acropetal succession. And if the rachis is suppressed, then we can say that the flowers present at the periphery are blooming or maturing first, and thereafter buds towards the center are maturing. So that is why it is called centripetal succession. Now in case of cymose, it is just the reverse. First of all, it ends in a flower. There is a flower at the apex, followed by some basipetal succession of flowering or blooming. That is, the bud at the lowermost position is the younger one, and the bud at the apex is the matured most. And if the rachis is flattened, then the bud at the center will mature first, and thereafter the peripheral buds will mature. So that is why it is called centrifugal succession. Now coming to different types of racemose. So racemose inflorescence can be divided into simple racemose and compound racemose. In case of simple, the rachis is unbranched, whereas in case of compound, rachis is branched. So we'll talk about the simple racemose types. So the simple racemose can be divided into two, that is flower pedicellate and flower sessile. In case of pedicellate flower types, there are three main types, raceme, corymb and umbel, whereas in sessile category there are 7 other types. These are spike, spadix, catkin, strobile, capitulum, capitate, and spikelet. Now, raceme. In case of raceme, peduncle is long, flowers are stalked, and arrangement of flower obviously acropetal. Example, Brassica nigra. So this is the basic of raceme, the basic diagram very. And in case of corymb, also peduncle short, just opposite of the raceme. Flowers are stalked, but arrangement will be acropetal. What is the striking feature of corymb is stalks are unequal. Lower the flower, longer will be the stalk. So this is the figure where we can see that lower the flower, the stalk is much more longer, and the flower approaches towards the apex, the stalk is much shorter. So that is why all the flowers are coming to a same plane. Example is Cassia sophera. Next, umbel. In case of umbel, rachis is suppressed to a point. Flowers are stalked, bisexual, and arrangement is centripetal. Example, Centella asiatica. So this is the figure how from a single point all the stalked flowers have emerged. So these three categories of stalked simple racemes are there. Now coming to the sessile categories. First of all, spike. In case of spike, peduncle is long, but flowers are sessile, bisexual. Arrangement of flowers obviously acropetal as it is a Racemose inflorescence. Example, Aerva aspera or Polyanthus tuberosa. And in case of spadix, it is more or less like a spike, but the peduncle is fleshy, long. Female flowers are present towards base, male flowers towards apex, and sterile flowers at the middle. And moreover, the whole inflorescence is surrounded by a spathy bract. Example, Colocasia antiquorum. So these are the figures. So on the left, this is spike, and on the right, this is spadix that is covered by a spathy bract. Now coming to the next, that is catkin. In case of catkin, peduncle is long, it is pendulous, and flowers are sessile, unisexual. Arrangement of flowers obviously acropetal. Example, Acalypha indica. And in case of strobile, peduncle is also long, flowers sessile but bisexual on contrary, and arrangement obviously acropetal. Example is humulus flowers. Now this is catkin on your left and this is strobile on your right. Point is at the base of each flower there is a bract. Now capitulum or anthodium or head. Now in this case peduncle is flat, convex shaped, and flowers may be bisexual, unisexual or both present. Arrangement is centripetal. In some capitulum inflorescence, the peripheral florets are called ray florets, which are sterile, showy, attracts pollinators, whereas in case of central florets, they are fertile, bisexual florets, and they are called as disc florets. Now, so the examples are Helianthus anus, Tagetes patula. Helianthus, that is in case of the members of Asteraceae, both the plants. So one is sunflower, Helianthus, and Tagetes, another. So marigold. So in both cases, you can see the peripheral florets are showy. They are colorful. They have bright yellow or bright red colors. But the central florets are more or less looks like a stick. Now, what we call a total flower of marigold or sunflower, that is biologically more than one flowers. So therefore there are more than one flowers, what we called a single flower of marigold or helianthus, that is sunflower. So this is the figure where we can see the peduncle is flattened, convex. There is disc florets at the center and ray florets towards the periphery. Next is capitate. In case of capitate, peduncle is suppressed to form a point or globose head-like structure on which large numbers of sessile bisexual flowers develop in centripetal order. Example, Mimosa pudica. So this is the image where we can see the central head-like peduncle on which sessile flowers are arranged centripetally. And this is the peduncle and this is the sessile flowers which are centripetally arranged. Next is spikelet. It is a short spike inflorescence, that is why it is called spikelet. But the characteristic feature is the whole spikelet is covered by glume. Within it there is another bract called lemma and a bracteole called pallia. Now this is found in the members of Gramineae like Oryza, Sativa, Triticum aestivum, so in case of paddy and wheat. So this is the image where we can see glume 1, glume 2, glume 3 is called lemma, followed by the bracteole pallia, then laudicule, and at the centrally placed the two essential holes, androecium and gynoecium. Now coming to the cymose type of inflorescence. So the cymose inflorescences can be divided into four major categories: solitary, monocasial cyme, dicasial cyme, and polycasial cyme. Again, monocasial cyme is divided into two types: helicoid and scorpioid cyme. Solitary, it is found in hibiscus, where we can see only a apical or axillary bud transforming into a single flower. So that is why it is called solitary inflorescence, and it does not form a real inflorescence. So the image looks like very simple, the solitary one. Next, monocasial cyme. The cymose inflorescence where the main axis terminates into a flower and one lateral branch along with terminal flower develops from its base. So that is why it is called a monocasial cyme, that is only one lateral branch is coming out at the base of each previous flower. So there are basic two types, one is helicoid and another is scorpioid cyme. In case of helicoid cyme, the lateral branches will develop on the same side of the flowering axis, forming a helix-like structure, and that is why it is called helicoid. The example is Myosotis or Hemilia. But whereas, now look at the picture of helicoid, you can see the lateral branches are coming out only from one side of the flowering axis. But in case of scorpioid cyme, the lateral branches develop on either side, alternating to right and left of the flowering axis or the inflorescence axis, and that is why it looks like a zigzag pattern. This is called the scorpioid cyme, and it is found in Ranunculus or in Boraginaceae family Heliotropium plants. Now coming to the dicasial cyme. So like as we said, in case of monocasial, at the base of the terminal flower there will be one lateral branch, but as di says there will be two lateral branches. So there will be two lateral branches along with terminal flowers. So each time lateral branches are coming out, there will be two lateral branches from the base of the flowering axis. So that is why it is called dicasial cyme. Whereas In case of polycaseal cyme, there will be more than 2 lateral branches along with terminal flowers developing each time from the base of the inflorescence axis. So that is why it is called polycaseal cyme. So dicasial you will see in Jasminum, in Dianthus. In Polycasium you will see in the members of Asclepiadaceae like Calotropis sp. And these are the respective images of dicasial and polycasial cyme. Now coming to the evolution of these types. So dicasial cyme or dicasium seems to be the most primitive one. From this, several lines of evolutions have drawn or predicted. In one line, by suppression of all lateral branches, solitary inflorescence may be developed. In another predicted line of evolution, if one-sided lateral branches are suppressed, then it will give rise to helicoid cyme. And from helicoid cyme, if the axis gets straightened, then it will develop corymb. Again, in another line of evolution, if suppression of lateral secondary axis takes place, then it will give rise to polycasium, and from polycasium, by suppression of pedicel, it will give rise to umbel. Similarly, in another central line of evolution, if alternate suppression of lateral axis take place, that is, once the right lateral axis is suppressed followed by the left lateral axis, then it will give rise to the scorpioid cyme. Now from scorpioid cyme, by straightening of axis, it will give rise to raceme. From raceme, where the flowers are pedicellate, if the pedicels get suppressed, then the flowers will become sessile, that is, it will give rise to spike, and spike is the central point where from by surrounding the spathe it will give rise to spadix. By flattening of rachis it will give rise to capitulum, or by suppressing the rachis to a central mass or central head-like structure on which flowers are arranged centripetally, it will give rise to capitate type of inflorescence. So therefore, these are the probable lines of evolution of Cymose and Racemose types of inflorescences. That's all for today.